few years, and that's what we're trying to work. I'm trying to work with him on processing the Clementine data set for Orbiter as well. These maps are better than Celestia, as I understand it. Okay, let's just go ahead into Mars orbit. This one is not a pre-recorded flight, so if you ask me to do loop-de-loops, I can go ahead and do that for you. Do we have any questions? Anybody else want to? Yes? No. Actually, you can. There is an option in Orbiter called unlimited fuel, but there is an understanding with the shuttle that the mass to fuel and engine ratio, when you're taking off, if you have unlimited fuel turned on, your shuttle is too massive. And if you try to go to orbit with that much mass, you'll never reach orbit. So what you do is you fly to orbit, you quick save, and then you go in, give yourself more fuel, turn off the limited fuel option, go back into your simulation, and you can go anywhere in the solar system with the space shuttle. So, yeah, yes.
I missed it. You said earlier, what kind of how specific can you be, like, for defining, say, the moments of inertia of your spacecraft? It's very, very specific characteristics that will allow you to really understand these things. I guess, how much detail can you go into when you design these spacecraft? I understand that would be a lot, but I don't know the specifics.
There is actually quite a bit. When we first got into this, there we go. It's freezing up there. I'm going to go ahead and time accelerate a little bit, and we can put this thing into a slow roll. That kind of really shows off the beauty. I'll get to your question here. Essentially, there's a little utility, the SDK, the software development kit that comes with Orbiter. Cyrus mentioned earlier that it has a very rich API, application programming interface to C++. This is written with DirectX in mind and Windows. It's kind of an old version of DirectX, but we do have a bunch of utilities that come with the SDK for texture maps, for working with moments of inertia. And we just released some new features in the new release and coming up in the new beta, a new rotation model. And it supports distributed masses on a vessel relative to perturbations of orbital elements, which gives some torque. So when you're orbiting up there in, say, a big long cylinder with a big rock at one end, it's going to tend to swing towards one end with the rock towards the end of the Earth and the light end facing up. Just because of the perturbations and the torque that's developed on that. And that's new. That's something that's just come out recently, especially with this new rotation model. And there's also, like I said, the utilities in there that it actually looks at the mesh. You feed it a mesh file, and you do a series of finite element analysis. It breaks that mesh down. It looks at the distribution of polygons, and it'll tell you what the moments of inertia should be, or what it thinks they should be. And it's reasonably accurate. It's moderately accurate to like 2 or 3 decimal places. So it's not too bad. Any other questions? Yes?
You mentioned a couple of times using the tether for gravity. Does Orbiter model tether dynamics, or is it treated as a long range model?
We do have the tether MFD. And it is tether dynamics. The one thing that Orbiter does not support yet is collisions detection. So the tether tends to be attached to the docking ports where it's defined as, and if it goes slack, the rope can go floating through the cabin, and it's kind of funny that way. But we are hoping for collision detection, and we are also hoping for a new lighting model. Right now there's only one light, that's the sun, so we don't have any flood lamps. Just recently in this version, there's atmospheric effects. So when you are orbiting around the night side or you're orbiting on sunset, you get a red tint on your ship for just a few minutes, which is pretty cool, especially when you're looking at the white space station and it just kind of turns red. It's yes?
What you perceive the learning curve and getting to be very proficient in this program is?
That's a really good question. We had a guy come to our table one of the volunteer security guys out here yesterday, and he had really no idea. I mean, he played Star Wars Galaxies, and I think he's, 17, 18 years old, and he really didn't know how orbital mechanics worked at all. And the last 2 days, he's picked it up. He can get to orbit, and he can orbital align with the International Space Station already. So you do have to apply yourself, because it's not game physics. It's not just going in and grabbing the joystick and flying all over. You have to know where you're going. Otherwise, you'll never reach orbit, and you have to know a few things about orbital mechanics. But it's not beyond anybody to not just be able to pick up, because, I mean, especially once you're drawn in, you're driven to find out how to make it work.
I have a follow-up question. Is there any, I mean, what are the principal limitations of orbital compared to something like, let's say, SDK, satellite toolkit kind of thing? I mean, what are the extents of orbiter simulation capabilities? What's missing?
There's quite a bit that's missing. One of the things that's missing is true flight planning. Our flight planning is kind of limited to the MFDs, the multifunctional displays that we saw earlier. You can do pre-programmed flight plans through the solar system. So you can actually tour the solar system like Voyager did, or Cassini, or Galileo, doing swing-bys and gravity assists and things like that. But it's not perfect. The precision is enough to the point where you can make it work, but you're continually making adjustments through the flight. And there's actually two tools, two MFDs that will do that. There's TransX, which is actually ships with orbiter. We tend to kind of think that it's a little bit difficult to use. Interplanetary IMFD, IMFD ships, we're going to be putting that out with the Mars Direct project. And that runs a little better. It uses OpenGL, so the MFD itself is 3D. And we think that tends to help. But anything that plans interplanetary trips is going to be kind of difficult by nature. So. Actually, I think I'm going to go into one of the things, some of the other accuracies that were expressed here. When we first got our new flight mode, I think I mentioned this a little bit. We got a new flight mode. Dr. Martin Schweiger developed this new flight mode, which is basic simulation stuff, forces from ailerons and things like that. And he tossed us the beta team. He just said, "Okay, guys, this is what I wrote. Go test it. And I don't know how it's going to work," and which is what he usually does, anyways. And we threw it in. I threw it in and started doing some testing. And the first thing I noticed is when doing like a re-entry with the Delta Glider, which is a fictional trainer, or the shuttle, I noticed that we started to get some oscillations. The nose started to hop a little bit. And the denser the atmosphere at that velocity, the more the nose hopped. And pretty soon it got to the point where it was really jostling. And if you really dove deep into the atmosphere, it would freeze for about 2 seconds, and then all of a sudden you'd find yourself traveling out of the solar system at 300,000 miles per hour, and the Earth would be about that big, even though you were reindeering about 2 seconds ago. What happened was the simulator, the new flight mode, actually used Bernoulli's numbers, which is a series of partial differential equations based on fluid dynamics. And it simulates in time series, because we were breaking this down into time steps, the lift-drag ratios on the wing surface area. And because of that time series, the discrete steps in the time series, it was actually causing the simulated fluid dynamics problem, which is a real aerospace problem, which causes that oscillation. And the space shuttle accounts for it by having super fast computers on board that correct for it in real time. The thing is, this is a simulator, and when that gets too tight, the Bernoulli numbers and equations were flipping those variables upside down. We were dividing by 0, and we get an infinite force on our ship, which causes it to kick out of the solar system. So we had to add a variable to the end of Bernoulli's equations to kind of dampen that out as it got worse. And at this point, it's pretty much as good as it's going to get. And it tends to dampen out pretty good. You can still make it crash, but you have to really try hard. So that kind of ticks on that. And Rich also talked about the Mercury flights. We do have the Mercury flight I mentioned before. We also have Gemini. We also have the Apollo. I think I mentioned that. And we actually have the Apollo recorded flights, I believe. So the audio from the Apollo missions and the Gemini missions, you can download from the websites, and you can play them along with, as if you were really there, historically doing those missions. Yes, yeah, let's not forget our Russian friends. The Soyuz, we have our Soyuz, we have our Energia, we have our Braun. We have
I think someone's working on
Shenzhou, that's right.
as well.
And I think also Falcon 9 is possibly being done. And the crew exploration vehicle, we've got, and going on to mention add-ons, we've got our flying cheeseburger add-on. We've got a bunch of others. We've got the fictional guys want their X-Wings and their TIE fighters and their Star Trek runabouts and things like that. So you've got people with their own agendas, just like anywhere. I mean, it's a public community. I mean, there's people that do anything. So, any other questions? Yes?
Wouldn't this make a great in-flight trainer for a long mission to Mars, through currents, and that's been done on the shuttle, I know.
It could, yes. It could. I mean, we're running it here on a laptop. It doesn't require any sort of rack-mounted supercomputers or anything. So we've built Orbiter to be very scalable, very scalable. In fact, that was Dr. Martin Schweiger's #1 goal, was to make Orbiter scalable so that anybody can run it. We made it so that we could run it on a low-end Pentium, on a Pentium 2. I used to run it on a Pentium 2. I'm running it on a Pentium 3 right now at home, even with these highest resolution textures. So that kind of gives you an idea of what is possible out there. Yes, and you can also video capture. There's proprietary video capture programs out there available, or screen capture programs. You just press a single key, like F12 or something. Yes. Bruce has a number of also things. He's very involved. Bruce is actually on our beta team as well. So there's a lot of stuff going on out here. And the best thing about Orbiter is it's always improving. It's always improving. Everybody here can tell you that we've been around since the very beginning, and we have this atmospheric haze now, against the horizon. We didn't used to have that.
Part of our idea with Mars Direct Orbiter is to generate promotional videos and graphics for the Mars Society.
That's one thing that we would like to do.
Technical assistance for the Mars Society since day one. Seth and I have both emailed Dr. Zucker, and he's always been very gracious to respond to us
Yes.
right away. And we've asked him a few times niggling technical questions that we couldn't figure out. He filled us in.
I'm going to go ahead and switch over to a Mercury flight if everybody would like to see that. It's kind of interesting. You want to hold the mic here while I switch? Okay. You can feel free to talk if you'd like. I think we could take a pick. Anybody want to pick which one you want to fly?
No, one thing about,
Freedom 7?
I'd start with friggin', why don't you start with the basic redstone? Yeah, one thing, it is an international community. People show up on the forum, they have ideas, they share them. And a lot of the add-on developers, I would say there's close to 500 different add-ons now. And as far as the learning curve, I found my own personal interest is, go ahead and do it historically. Launch a suborbital Mercury first, then do your orbital. Then when you get to the Gemini, you do rendezvous and docking. But then you move up to Apollo, then you get to the moon. And then now finally with Mars Direct and the interplanetary MFDs, it's possible to do a very accurate flight to Mars and back. So as far as the learning curve, I would say, get the historical scenarios and play them in the historical sequence.
There was one other thing that I wanted to mention with Mars, relative to Mars Direct. I personally have some goals within Mars Direct that kind of extend beyond. And Cyrus I've talked with Cyrus about this, possibly allowing the HAB to Titan, to do a Hab to Titan flight. And then there's also some possibilities of developing a Super Ares with like 200 tons plus to low Earth orbit for space station building. I'm working on Zeus station modules. You want to go ahead and fly that while I'm running here? So there's a lot of other things. You can show them the control panel too. The Zeus control panel, or the Zeus station builder. So there's space station components that you can launch and assemble them on orbit, in orbiter. F8, isn't it F8? Oh, is it frozen? Maybe it is. This is a beta version of orbiter, so it tends to be a little bit buggy yet. Try it now. Do we have sound?
Yeah. One of the nice things we did with this Mercury simulation is we actually used the scripts in the actual launches, and we had a bunch of the orbiter community get together in a voice chat, and we recreated. If you download this, one of the people you'll hear on the admission control is me. So I thought that was really cool. Go ahead, Seth.
Yeah, I think I did mic check 1, 2, 3 mic check on when we were looking at some of this stuff.
I'm one of the guys going, go.
As I was mentioning before, we have the ability to launch payloads and assemble them on orbit. I showed you the shuttle earlier. The shuttle has a working RMS. The RMS can grapple objects out of orbit, put them back in the payload, and you can return to KSC and land with the payload still in the cargo bay. So there's some pretty amazing stuff there. I can't hear. Another one of the features we're looking at supporting in orbiter is clouds. Obviously, this is just a cloud plane. It's not a true cloud simulation. And weather would go with that as well. That's not something that's supported yet. Here we come on separation. And there goes our music again. Oh, we almost hit the escape tower there. There should be a retro pack on there. That's really quite fascinating to be able to do this. And it auto guides here. Show them the control panel again. Go back inside. There's more to the control panel than you saw, just the one. F1. There we go. Okay. This is the part of the control panel that I did. This part right here is something that has been done a while. It's been kind of on hold. Switch box. And some of these switches actually function. I don't want to jettison my stuff just yet. But we go back here, and then over here is the communications panels, and we've got an alarm panel here, retro alarm. Some of these alarms will actually go off. It gets kind of annoying, so we might end up not doing that. But if you actually look at the control panel, the manual to fly this mission, a lot of the stuff in the manual is the stuff that you would see if you were really going to be getting in the actual capsule and doing your own Mercury flight back in the day. So that's another part of the draw that makes this so exciting. Do we have any more questions? Anybody? We've got some new people that came in, so. we would love to have astronauts be using some more of this. We think they will be very interested in some of the things that can be done with Orbiter on a whim. Yeah, you want to time accelerate? Yeah. Oh, we got an alarm. Uh-oh. See, it can be still a little bit buggy from time to time. Yeah, let's just turn that down. Go ahead. The reentry, of course, gets kind of interesting. We buffet it around a little bit. Now, like I said, it does support all these flight modes. So one of the challenges in Orbiter is progressive challenges. First, of course, attempting to get to orbit, or doing a suborbit flight and being able to land on the runway for some of us. And then actually being able to get to orbit, and then setting an orbit where you can go into an orbit and have a target plane like the International Space Station. And after that, of course, you want to be able to shoot for the moon and hopefully come back. So then, of course, you want to go to Mars. One of the last challenges that you look at doing is actually being able to do a landing at KCS with the space shuttle on a full orbit, doing a full space shuttle mission from ascent right back to landing. And that that's actually very challenging in here.
We actually have a simulation of what the GPC is, the computer system NASA uses on the actual shuttle.
Yes,
we
yes.
load it as an MFD on the shuttle.
Yep.
And it works exactly, precisely the same.
So you can fly the hack after you've done your reentry. We got the. There we landed. We landed.
Seth, are there any tutorials for Orbiter?
Lots of tutorials. And it's good you bring that up, Bruce, because Bruce is the one who's got the best tutorial. Go Fly in Space is his book that he's written. I should show that. Thank you for bringing that up, Bruce. Bruce has written this excellent book, Go Fly in Space. There we go. It's second edition. We're hoping to send that to print, actually, and sometime in the future. So there's a chance that you might be able to buy a full color copy eventually. I guess that's we're wrapping it up now. So thank you very much for coming, everybody.